These are notes from Melham's Math 70 for Friday, April the 24th, section 12.1, page 695. This is the beginning of the last chapter. Chapter 12 was on probability. Remember, you also have a quiz today. Maybe you might want to defer doing the lesson for today until after you do the quiz. Remember, you have a quiz due at 11:59 p.m. tonight, Friday, the 24th of April. But here's a lesson for 12.1, page 695. The topic today is counting principles. Some are easy, some are a little bit harder or more complex. So, number 2, they want you to give a sample space. Sample space means write it as a set. Remember a while back we did set notation, which is putting stuff in braces. So number 2, an odd single-digit whole number. Well, that would be 1, 3, 5, 7, and 9, and that's all there is to it. Number 4, select a month. So that's obviously January, February, March. I just did ... December to save time. You would have to write all 12 of them out, January, February, March, April, and so on. But just enough to give you the idea, January, February, March, ... continue all the way to December. Okay, so those problems are very easy. Now the ones later on get a little bit tougher. Number 6, toss a coin 3 times. And there's 8 possibilities. We have talked about that kind of thing again, where if there's 2 choices, there's 2 choices for the first toss, either heads or tails. There's 2 choices for the second toss, heads or tails, and there's 2 choices for the third toss. So that's going to be 2 times 2 times 2, or 8 total possibilities. And here's the way I break it down. You have 4 choices where heads comes up first. So I put H, 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 H. And you have 4 possibilities where tails comes up first. Tails, 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 tails. And now that that's out of the way, for the second and third tosses, you have 4 choices. Heads, 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 tails, tails, heads, tail, tail. And that 4 combination, you can just kind of copy and paste that down here. H, 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 T, T, H, T, T, giving you the 8 possible choices. And we've seen variations of that theme before. So that leaves us with 8 possibilities. So again, think of heads coming up first, H, 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 tails coming up first, T, 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 T. Then after that, for the second and third tosses, you have 4 choices, H, 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 T, T, H, T, T. Just take those same things and put them over here. Number 8, it says toss a coin, 2 choices, and then choose a number from 1 to 4. So that's 8 total possibilities, which is 2 from here times the 4. Easy way to break it down is the coin can come up either heads or tails. So I put H, 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 T, 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 T. And then once that's over with, then you pick 1, 2, 3, or 4. And likewise tails, 1, 2, 3, or 4. Right, so that 8 possibilities. 10 is a little bit more involved. It says you can choose 3 body styles for the car. Let's call it B1, B2, B3. You have 2 possible radios, call them R1 and R2. 2 possible interior colors, call them I1 and I2. So the total possibilities is you just multiply 3 times 2 times 2. 3 times 2 times 2 is 12. And here's an easy way for me to break this down. For the body style, I can pick either B1, B2, or B3. So on this line right here, they're all B1. Notice B1, 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 B1. This line is all B2, 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 B2. This one is all B3, 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 B3. Once that's out of the way, I now have 2 choices for radios, 2 choices for colors. It's sort of like the same situation as over here. So I can pick R1, I1, R1, I2, R2, I1, or R2, I2. Just copy and paste that for all of them. Right? So once you have B1, or B2 or B3, now I can pick R1, I1, R1, I2, R2, I1, or R2, I2. Just write that down and copy and paste that all the way down here. Problem 12 is a little bit tougher. It says you have to start at A, and then after that you go through all the other letters exactly once, which means once you pick A, there are 4 choices for the next letter, B, C, D, or E. And then you have 3 choices after that. And then you have 2 choices after that. And then you only have 1 choice after that. So there should be 24 total possibilities. Okay. here's the way that you can think of the 24, writing them all out. First, they all have to start with an A. So you see I have 24 of this, I just put down A's. Okay. Now, the next letter can be either a B, C, D, or E. Here's the way I figured out. Once B is chosen, okay, then you have C, D, and E left. You have 3 times 2 times 1, 6 possibilities. So what I did was put B, 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 6 possibilities. Then C, 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 6 possibilities. Then D, 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 6 possibilities. Notice in each case A is first. Then E, 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 6 possibilities for E being the second. And once again, A has to be first. They said A is first. So for all of these, A is first. And then B can come second, 6 ways. C can come second, 6 ways. D can come second, 6 ways. E can come second, 6 ways. Okay, and after that, you have 3 letters left. So we're down to 3 times 2 times 1. So that's what we have. Okay, so starting from A, B, the next letter can be a C. So I put that twice. The next letter can be a D. I put that twice. The next letter can be an E. Put that twice. Okay. So once you have A, B, C, so this top line is A, B, C, then you can choose either D, E, or E, D. Then the second line is for A, B, D, A, B, D. Now you can either have C, E, or E, C. And then the third line is A, B, E, A, B, E. Then the only choices are C, D, or D, C. So that exhausts all the possibilities for A and then B. And you have the same kind of game happening for A, then C, A, then D, A, then E. So here, supposing you start off with AC, then I've got possibilities of the next one being D. So I put D, and that would be BE or EB, or the next letter being E, which would be BD and DB, and so on. So if you follow that logic all the way down, this gives you all the 24 choices. Might be a little bit tricky to follow it, but think of going letter by letter. They've all got to be A. Okay, the next one's got to be B. I know that after that you have 6 choices, so I put down B 6 times, C 6 times, D 6 times, E 6 times. And then you think of the third letter. Okay, and once you have the third letter down, like C, then all you have are 2 choices left. You either switch the other 2 letters around, and that's about it. 14, it says 2 digits from 1 to 4 with replacement. With replacement means you can pick the same number again. So you're allowed to pick 1, 1, or 2, 2, or 3, 3, or 4, 4. So the number of total choices is simply 4 times 4, or 16. Because you can pick 1, 2, 3, 4, 4 choices. And the second time you can also pick 1, 2, 3, 4. That's called with replacement. So 16 total. Number 16, you're given a true-false test and you have 25 questions. How many different ways can you answer the test? Well, it's simply 2 to the 25th power. We talked about something like that before. So the first question, you can pick either true or false, 2 choices. Second question, again, either true or false, 2 choices. All the way down to the 25th, it's still true or false, so it's 2 to the 25th power. Punch it in your calculator, 33554432. Finally, 18 is a little bit tricky, and I'm going to interpret it a little bit differently. If you read the question, you might interpret it differently than I am, but I'm going to make this interpretation. The first letter, the first character has to be a letter from A through H, and then after that, you have to have a digit between 1 and 9 and no repeats. If you read the question 18, there's a chance that somebody might interpret it as the location of the letter can be anywhere in here. So in other words, the letter might be here or here or here. That's a slightly harder problem, but I will make this interpretation. So I'm changing the problem. It may not match what's in the back of the book, but my interpretation is you first have to start off with a letter from A to H. Then after that, you have 5 digits, none of which is repeated. So to do that one, you have 8 choices for the first character, A, B, C, D, E, F, G, H. Okay. And then these are all numbers, but no repetitions from 1 to 9. So from 1 to 9, obviously you have 9 choices. But once you pick one of the numbers, you're no longer allowed to repeat it. So let's say I put down the number 3. Well, the second time, I don't have 9 choices. I only have 8 choices because I'm not allowed to pick 3 again. So now you have 8 choices. Let's pretend the second number was a 7. Okay. Now I'm no longer allowed to pick 3 or 7. So instead of 9 choices, you have 7 choices left. Okay, and likewise, once that's down, you have 6 choices, and finally 5 choices if these all must be different. So the total possibilities is 8 times 9 times 8 times 7 times 6 times 5 comes out to be 120,960 possible passwords for this combination. All right, so these are notes for Friday, April the 24th for Melham's Math 70, section 12.1, page 695. Remember that you have a quiz that's due today, and so check the email or Canvas for the quiz due at 11:59 p.m. tonight, Friday, April the 24th.